Hey guys, what's going on? Hope everybody's doing well, staying healthy, trying to enjoy themselves and be productive while they're home. The weather's been nice the last few days, so hopefully you've gotten a chance to get outside and do something fun. So today's lesson, we're kind of moving on to something a little different. I appreciate you taking the time to do that solving, going back to those special angles review. You'll see why I had you review them. Hopefully, from what I saw from your submitted assignments, everybody did pretty well. I was happy to see that. So hopefully you'll see the connection here today. So what we need to do is we need to solve trig equations. Basically, we're going to be given an equation that involves a sine, a cosine, tangent, something like that. And we're eventually our answers here are going to be special angles, and they're going to be in this interval from 0 to 2 pi. Notice how 0 is inclusive. Notice there's a bracket here. All right, and 2 pi will be a parenthesis, meaning it's not going to be inclusive. All right. When you're going through these, if you struggle with sine or cosine or anything like that, like just kind of ignore them in the beginning and just kind of make them come back in your answer. You'll see what I mean by that. But we're going to just kind of treat this first problem here as if it had just said x squared. Then the sign really wasn't there. Meaning, just go about solving an equation, getting x by itself, isolate the variable. So the first thing you would do here is add 1 to the other side. All right. Now this video might be a little lengthy today because there's a decent amount of writing here, and I got to get back to my practice with using my little touchpad as I write these. Okay, so just add 1 to the other side. Okay, and continue to get this sine squared x by itself. So we're going to divide by 4. And that would give us sine squared x equals 1/4. All right, so we're just trying to isolate the variable here, but the variable in this case with trig equations is not just x squared. It's also, in this case, sine squared x. All right, so sine is with it. So now we've isolated it. We've got it by itself, right? Except at this point, it says x squared, and we know we need to solve for x. So just like you would do in an algebra equation, we are now going to take the square root of both sides. All right, and now we have sine x equals the square root of 1/4 is a half. But we know that anytime we take the square root of both sides, our answers here will not only be positive, but we'll also have a negative answer as well. So plus or minus 1/2. Now here's where the special angles come in. Okay, because our answer here isn't x equals plus or minus 1/2. Our answer is going to be, well, what value, what angle has a sine coordinate, and sine is y, right? So what angle has a y coordinate of plus or minus 1/2? So we got to think about our special angles. Think about the pi over 6, pi over 3, pi over 4, all those that you worked with the other day. And you would recall that, okay, if the y coordinate's a half, well, we must be working with this point, root 3 over 2. And the y coordinate, as we just said, is going to be a half. So we're working with whatever special angle has this point, and hopefully we know that the special angle that has this point is pi over 6, right? Now, we found y not only to be positive, but also negative. So which quadrants would have a positive and negative 1/2? Well, all 4 of them do. So this wouldn't be the case for every problem, but for this particular problem, our answer is going to not only be pi over 6, but it's going to be all of the angles in the 4 quadrants with denominator 6. So pi over 6 is an answer. 5 pi over 6. In quadrant 3, you have 7 pi over 6. And finally, in quadrant 4, 11 pi over 6. Now, if you don't remember them exactly, hopefully you remember the whole idea of 1 more than or 1 less than, right? So these 4 angles are our answers. Okay, we'll box them in there. and one more than or one less than. So just think of this point. We know this point is pi, but since I'm working with denominator 6, just think of it as 6 over 6. One less than 6 would be 5, one more than 6 is 7, and that's where maybe you'll remember 5 pi and 7 pi over 6. 2 pi, another way to think of that, we know is 12 over 6 in this case, and 1 less than 12 is 11. So that whole idea of 1 more than or 1 less than, we'll use in each one of these problems as we try to figure out our special angles. Okay? All right. Next one. All right, so in problem 2, it reads, we have root 2 times cosine x plus 1. So again, we just want to isolate x just like we would in any equation, except here it's just cosine x that we need to isolate. It's a trig equation. So I'm going to subtract 1, and then I would divide by root 2. All right, so I'm just trying to explain that rather than have to write all that. But we're going to get cosine x. After I subtract 1 to the other side, and then I divide by root 2, we would get cosine x equals negative 1 over the square root of 2. All right, so cosine x equals negative 1 times root 2. Or, I'm sorry, negative 1 over root 2. Now, we know we can't have a radical in the bottom, so we would have to rationalize, which means multiply the top, right, and bottom by the square root of 2. And what we should be working with here is special angles, right? Our answer is going to be in special angles. So the values that we should be solving for as we go about these should be the values that we know make up the points of our special angles. So in this case, once I rationalize, I now have negative root 2 over 2, okay? That's not our answer. Remember, our answers are going to be angles. Now we ask ourselves, well, cosine is x. What special angle has an x value of negative root 2 over 2? So hopefully we see this point here. And by now, hopefully we know that the special angle we're going to work with here is pi over 4. All right, now our answer here, cosine x is negative, right? So which two quadrants would have a negative x value? And that would be quadrant 2 and quadrant 3. Okay, so our answer isn't pi over 4. That's our reference angle. The two answers that for here is going to be the answer that, or the angle that's in quadrant 2 and the angle that's in quadrant 3. So just think 1 more than or 1 less than. So 3 pi over 4. And in quadrant 3, is 5 pi over 4. Okay? Those are our two answers. All right, I got 2 more examples, guys. All right. So we got to think of all our different solving methods that we know, right? If I just basically took like all the trig parts out of these problems, we should be able to solve these because they're like basically like algebra 1 type equations. In this case, another way that we might want to think of this problem is just think of it as, picture just getting x squared minus x equals 0. And how would you go about solving for x here? Right? Well, if your answer is GCF, like factor out an x, you're right. So yeah, we would factor out an x, and we would have x minus 1, and we would continue then to set our factors equal to 0, and eventually solve for x, right? Well, we're going to take the same mindset here. I'm basically going to do the same thing I just did, except I'm going to put tangent in front of both of these x's, all right? So we're going to look to see what we're given. We need to solve for x, and in this case, we have to know this method of taking out a GCF, right? So for the next 2 problems, for this one and problem 4, we are factoring. In this case, we're taking out a greatest common factor, which is tan x. If I do so, I'm left with tangent x minus 1. All right. Now, just like we did up here, we would have to continue solving by taking each factor, x and x minus 1, and setting it equal to 0 and solving. So I'm going to do the same thing. I'm going to set tangent x equal to 0. And I'm going to set tangent x minus 1 equal to 0. All right, as I do that, I noticed I left out an x right here. So this still had an x. Okay, so if we take each factor, set it equal to 0, and solve, now we're going to get tan x equals 0, and we're also going to get tangent x to be positive 1, right? Once we add 1 to that other side. Okay, now we're not done yet. Now our answer, now we have to begin to think about how we're going to get that answer by saying to ourselves, all right, well, what angle would give me a tangent of 0? You know, what angle, when I take its coordinates, y, and divide by x, can I possibly end up with 0 as the result? Well, for us to get 0 when we're dividing, the numerator can be 0. The denominator can't be, or else it would be undefined. So in that case, x, and we're working with our special angles here, we know that x needs to be 1, but it could also be negative 1, right? So our answer, the two angles that would come from this, are going to be the angles that would give us a tangent value of 0. In other words, the angles that are at 0 and the angles that are here on the x-axis. So we know that this one's 0 and this one's pi. All right, so 0 is an angle. Now, if you thought 2 pi, technically you're not wrong, but we want to stay within that interval like we mentioned in the beginning. We're staying between 0 and 2 pi not inclusive. So here's 2 of our answers. We're going to work over here, get 2 more. All right. Which special angle could give us a tangent of 1? So which angle, when I take y, divide by x, can I possibly get 1? Well, y and x must be itself. And the only special angle that would allow us to get that would be pi over 4, right? Root 2 over 2 divided by root 2 over 2. Well, think about where or which 2 quadrants could give you a positive tangent. All right, quadrant 1 can, and so could quadrant 3. So our other 2 answers would be pi over 4, because that's in quadrant 1. Right, our reference angle is always in Q1. And then in quadrant 3, five pi over 4. All right, those are our answers. All right, guys. Last problem. All right, doing well. Remember, hopefully as you go about answering these or as you're taking notes, you are pausing it, maybe rewinding it if you missed something. But guys, you know, it's going to be different. It's going to be, but I promise you, we'll go slow. We'll do a lot of practice, just like we did with the verifying questions. And by the end of it, I think you guys will have a really good understanding of this. Okay. All right. So again, just picture being given this problem without cosine, right? It would be x squared minus 3x plus 2. So I'm not going to write this one out in its entirety, but I'm not going to solve it. But just picture it said this. Well, not cosine, I said, right? So you're just going to take out the trig functions and just picture that this was just some basic algebra factoring problem that you had to solve for x. So you would know to separate it into 2 parentheses, figure out factors of 2 that can give you -3, check your signs and all that. We're going to do the same thing here, except in front of each x, it's just going to say cosine x. All right. So my first step, I'm not factoring out any GCF here. I'm factoring trinomials the same way we would doing a basic algebra problem. So cosine x and cosine x, and I'm thinking of factors of 2, and 2 is a prime number, so it's pretty easy, that are going to give me 3. All right, so it's obviously 2 and 1. We just got to make sure the signs match up right here, guys. So if the last sign's positive, we can get a positive by multiplying 2 negatives. These would add to -3, so we factored correctly. And just like in the last problem, after we factor, we would take our factors, we would set them equal to 0, and we would solve. So I'm not going to show all of that. I don't think I need to. But cosine x would give us, we would get 2, and we would also get 1. Right? So the first part is just solving for x, or solving for whatever trig value in x, in this case cosine x. And then after you get it down, after you do that, now it's, well, what special angles have those values? So in this case, what special angle has a cosine, which is x, of 2? All right, and the right answer is none of them do, right? There is no special angle that we have inside our unit circle with radius 1 that would give us an x value of 2. All right, so you would just ignore that. All right, there is a special angle with an x coordinate of 1. Right, and that angle, the x coordinate's 1. Well, that angle's right here, 1, 0. Okay, and what angle is at 1, 0? 0 is. All right, so again, the x value is equal to 1. We know this point, right, on the x-axis is 1, 0. But our answer is an angle, and the angle is angle 0. Now, if you thought 2 pi, again, well, just go back up here to the directions. 0 is inclusive, not 2 pi. And if you think about it, we really have a limited amount of answers if I didn't give this interval, right? Because we can just continue to go around and around in a lot of circles. So it's just confined to one time around the circle. 2 pi is not inclusive. Anytime you're right here, your answer is 0. Okay? Anytime you're right there, your answer would be 0. Well, anytime you're right there as far as the angle, right? That angle is angle 0. All right, guys, watch this video. In addition to the video, I'll post an assignment. I was late getting this out today. I apologize, but I will going to just extend it. So just get it done sometime tonight, okay? And make sure you do it for tomorrow. All right, enjoy the rest of the day. I hope everybody's doing well, and I'll talk to you soon.